Welcome to our Spring Boot tutorial series. Today, we're diving deep into understanding the Bean lifecycle in Spring Boot. This topic is essential for developers looking to leverage the full power of the Spring framework, as it provides the foundation for dependency injection and bean management, two core features of Spring. In this video, we'll start by defining what a bean is within the context of Spring and why it's crucial for your applications. We'll then walk through each stage of a bean's life, from creation to destruction. You'll learn about how beans are instantiated, initialized, and destroyed within the Spring container. We'll also cover advanced topics like the various callback interfaces and annotations that Spring provides to hook into the Bean lifecycle. Whether you're just starting out with Spring or you're a seasoned developer looking to refresh your knowledge, this video will arm you with a deep understanding of how Spring beans are managed throughout their lifecycle. So, let's get started and unravel the complexities of the Spring Bean lifecycle together.
What is a Spring Bean?
In the world of Spring, a bean is an object that is instantiated, assembled, and managed by the Spring IOC container. IOC, or inversion of control, is a principle where the control of objects is transferred from the code itself to a container or framework. Beans are created with the specific scope of solving a problem or performing a function in your application. They are configured using simple configurations that you can manage and maintain easily. Each bean can be singleton, prototype, or request session scoped, depending on how you configure them. Singleton scope means a single bean instance per Spring IOC container, while prototype scope defines a new bean instance every time it is requested. Now that you understand what a Spring bean is and how it can be defined, we can delve deeper into their lifecycle, which we will cover next. This knowledge will enable you to utilize the full power of Spring, crafting beans that are efficient, scalable, and right fit for your applications.
What is Bean lifecycle?
Just like any living organism, the life cycle of an object in programming describes its birth, behavior during its existence, and finally, how it is destroyed. Similarly, in the Spring framework, a bean, essentially an object managed by Spring, undergoes a specific life cycle. This life cycle details how beans are instantiated, the actions they perform while they are active, and eventually, how they are destroyed. The life cycle begins when the Spring container creates the bean. The constructor specified in the bean definition is called creating a new instance. Post-instantiation, the container injects necessary dependencies into the bean through constructor arguments or setter methods. Next, if specified, a custom initialization method runs. This is often annotated with @PostConstruct and handles any setup required before the bean is ready for use. The bean is now active and performs its intended functions, whether that's data handling, web request processing, or other tasks. When the application context closes or the bean is no longer needed, a custom destroy method executes, typically annotated with @predestroy, to handle resource cleanup like closing connections or releasing handles. Let's visualize the bean lifecycle within the Spring container from declaration to destruction through a detailed flowchart. Our journey begins with the bean definitions declared stage. In Spring, beans can be declared in multiple ways, through XML configuration files or annotations like @component and @configuration. Once bean definitions are declared, we move on to the bean definitions loaded stage. Here, Spring uses classes like XML Bean Definition Reader for XML configurations and ClassPath Bean Definition Scanner to scan the application's class path for classes marked with stereotypes like @component, @service, and so forth, automatically registering them as beans. These tools are critical for gathering all the necessary information about the beans. Next up is bean definitions processed. Before any beans are instantiated, BeanFactoryPostProcessors come into play. They modify the bean definitions, allowing for sophisticated configuration management, such as property resolution or method overrides. Now we reach a crucial phase: beans instantiated. The Bean Factory kicks into high gear, creating bean instances using their constructors. It's like bringing the blueprints to life. Once beans are instantiated, we enter the dependencies injected phase. Spring injects required dependencies into the beans either through setter or constructor injection. This is where Spring's dependency injection magic shines, wiring everything together seamlessly. Before beans are fully initialized, they pass through the beans post-processed phase. Here, bean post-processors might tweak the beans, doing things like setting additional properties or applying custom business logic. Moving on to beans initialized. In this phase, beans are initialized with methods annotated with @PostConstruct, ensuring that the beans are ready to perform their duties in your application. Even after initialization, beans might go through another round of post-processing. This could involve wrapping beans with proxies to enable functionalities like transactions or security aspects or resolve circular dependency.
Now, the bean is fully operational and live in application context. At this point, beans are actively participating in your application, serving their purpose as configured.
Finally, we reach the end of the lifecycle, beans destroyed. When the application shuts down, beans are cleaned up. Methods annotated with at predestroy are called, allowing beans to release resources and shut down gracefully. This comprehensive overview gives us a clear insight into how beans are managed in a Spring application. Each stage is critical for ensuring that beans behave as expected and that resources are managed efficiently.
Before we start, let's clean up our project by removing all controller classes except for the custom scope controller. Let's now remove the scope annotations from English Greeting Service, Hindi Greeting Service, Greeting Service Simple, and Spanish Greeting Service. This will ensure all services default to the singleton scope, simplifying our Spring Boot application's configuration. Next, we'll delete the entire scope package and all classes within it from our project. Rename the custom scope controller class to GreetingController. Now, let's refine our GreetingController class. We'll remove the Greeting Service Object Provider variable and replace it with a new variable named Greeting Service of type Greeting Service. We also need to update the constructor to reflect this change, ensuring it accepts a Greeting Service parameter instead. Let's continue refining our GreetingController. We'll change the URL mapping to /greetings and rename the method to greeting. This method will now return the response from greetingservice.getGreeting. In our final adjustment for today's session, let's remove the count variable that we previously added to our greeting service classes. Suppose you need to perform some actions right after the English Greeting Service object is created, like initializing resources or loading a greeting template. You might wonder how to achieve this in Spring. Well, don't worry, Spring provides a neat solution for this. Once a bean is created, Spring offers you the opportunity to execute additional initialization code. This is done through the @PostConstruct annotation. By annotating a method in the English Greeting Service with @PostConstruct, Spring ensures that this method is called immediately after the bean's instantiation and dependency injection are complete. Absolutely, let's go through defining an initialization method in English Greeting Service and annotate it with @PostConstruct. Spring doesn't restrict you on the method name, so you can choose any name that makes sense for your application context. To verify that our initialize method is being called at the right time and to understand when it occurs in the lifecycle of our bean, we can add a system.out.println statement within the init method. This will provide a clear console output indicating when the method is executed. Suppose you need to perform cleanup tasks such as closing database connections or releasing input streams when a bean is destroyed. So how can we do that? Well, don't worry, Spring offers a straightforward solution for this scenario. You can define any method within your class and annotate it with @predestroy. Spring will ensure that this method is called just before the bean is destroyed. This feature is perfect for efficiently handling necessary cleanup tasks. Let's define a method named cleanup in the English Greeting Service class and annotate it with the @predestroy annotation. This method will handle tasks such as releasing resources before the bean is destroyed, ensuring that our service cleans up properly. To confirm that our cleanup method in the English greeting service is being called at the right time, let's add a system.out.println statement. Start the application. As observed in the logs, the lifecycle of the English greeting service within our Spring application begins with the initialization phase. Initially, Spring calls the constructor of the English greeting service to create an instance of the bean. The first log entry typically shows the instantiation of the service, indicating that Spring has created an instance of English greeting service by calling its constructor. Following the instantiation, Spring proceeds to the initialization phase. Here, Spring calls the method that's annotated with a PostConstruct. This annotation tells Spring that the method should be executed right after the bean's construction and dependency injection, but before it is made available for use by other parts of the application. Next, stop the application. When we stop the application, as observed in the logs, the cleanup method in our English greeting service is called. This is an important part of the Bean lifecycle managed by Spring, ensuring that resources are properly released and cleaned up before the application shuts down. As the application context begins to shut down, Spring systematically destroys the beans it manages. Spring triggers the @predestroy annotated cleanup method on the English greeting service. This method is designed to handle tasks such as closing database connections, releasing file handles, or cleaning up any other resources that were allocated during the lifetime of the bean. In addition to using annotations like @PostConstruct and @predestroy, Spring offers another approach for managing Bean lifecycle events through interfaces. For initialization, Spring provides the InitializingBean interface, which includes an afterProperties set method. This method is called after the bean properties have been set by Spring, making it an ideal place to perform any initialization that depends on those properties. Let's implement this interface in the English greeting service and override the afterProperties set method to include a log statement. This will help us verify that it is being correctly called after the bean's properties are initialized. For managing cleanup when a bean is destroyed, Spring provides another useful interface called DisposableBean. This interface includes a destroy method, which Spring will call just before the bean is destroyed. This mechanism is particularly useful for performing cleanup tasks such as releasing resources similar to the @predestroy annotation but integrated directly with Spring's lifecycle management. Let's implement this interface in the English greeting service and override the destroy method to handle cleanup tasks. This will help ensure that our service closes resources properly when the application context is shutting down. Start the application. As we've observed in the application logs, the afterProperties set method is indeed being called after the bean's initialization. This confirms that the InitializingBean interface is working as intended within our Spring framework setup. Here's what happens in sequence. Spring first creates an instance of the English greeting service by calling its constructor. This is the initial step where the bean is merely instantiated. Following the setting of properties, Spring automatically calls the afterProperties_set method. This method is designed to execute any additional initialization tasks that need to happen only after all the bean's properties have been set. Stop the application. As we can see from the logs, the destroy method is being called when the application is stopping. This observation confirms that the DisposableBean interface is effectively integrated into the lifecycle management of our Spring application. When the application context begins to shut down, Spring starts the process of cleaning up the beans it manages. As part of this process, Spring calls the destroy method on beans that implement the DisposableBean interface. This method is specifically designed to handle cleanup tasks that must occur just before the bean is completely destroyed. While the InitializingBean and DisposableBean interfaces provide a structured approach to manage initialization and cleanup in Spring, it's generally considered best practice to use the @PostConstruct and @PreDestroy annotations instead. Using the @PostConstruct and @PreDestroy annotations helps reduce the coupling between your classes and the Spring framework. When you implement interfaces like InitializingBean and DisposableBean, your classes are directly dependent on Spring-specific interfaces, which can make them less flexible and harder to use outside of a Spring context. Annotations like @PostConstruct and @PreDestroy make the intent of the code clear at a glance without having to implement any interface methods. This can lead to cleaner, easier to understand code. With annotations, you are free to choose any method name and use any required parameters, offering more flexibility than the fixed method signature required by interfaces like afterProperties_set and destroy. Now, let's proceed to remove the InitializingBean and DisposableBean interfaces from the English greeting service. Suppose you want to access the bean name of your English greeting service within the service itself. Spring provides an interface called BeanNameAware for this purpose. When a bean implements this interface, Spring injects the bean's name into it via the setBeanName method. This can be useful for logging, auditing, or any functionality where knowing the bean's name could be beneficial. Let's implement this interface in the English greeting service and override the setBeanName method to print the bean name, providing insight into how Spring manages and identifies beans internally. Start the application. We forgot to update log statement. Let's update the log statement in the setBean name. Restart the application again. As we observed in the logs, the bean name for our English greeting service is the English greeting service. This matches exactly with how we define the bean in our Spring configuration. This correspondence is due to the @component annotation we used just above the English greeting service class declaration. In the annotation, we specified the bean name explicitly. Now, let's proceed to remove the BeanNameAware interface from the English greeting service. Implementing the BeanFactoryAware Interface is another way to enhance interaction with the Spring framework from within your beans. This interface allows a bean to be aware of and interact with the bean factory that created it. When a bean implements BeanFactoryAware, it can obtain a reference to the Spring Bean Factory itself, which can be useful for more advanced configurations or for programmatically retrieving other beans. Let's proceed to implement the BeanFactoryAware interface in our English greeting service. This will allow us to directly interact with the Spring Bean Factory, which is a powerful feature for managing beans dynamically within the application context. By overriding the setBeanFactory method, we can utilize the factory to access other beans and check their availability. As we can see on the screen, the Bean Factory in Spring provides several useful methods that allow us to interact with the beans managed within the Spring container. ContainsBean method takes a bean name as input and returns a boolean indicating whether a bean with that name is present in the container. It's particularly useful for checking the existence of a bean before attempting to use it, which helps in avoiding no such bean definition exception. GetBean methods are used to retrieve a bean from the container. You can specify the bean either by its name or by its type. If the bean is found, it is returned; otherwise, Spring throws an exception indicating that the bean could not be found. Inside the setBeanFactory method, we use the ContainsBean method of the Bean Factory to check whether the greeting service impl bean is registered in the container. This check is useful to ensure that the dependencies or related services are available as expected. Start the application. The log output indicating true confirms that the bean is indeed present in the container, exactly as we expected. This demonstrates that our Bean Factory setup in the English greeting service is correctly interfacing with the Spring container, allowing us to dynamically check and interact with the beans it manages. Let's now proceed to remove the BeanFactoryAware interface from the English greeting service. As we've previously seen, Spring does indeed call the @PostConstruct and @PreDestroy methods for beans. However, let's consider what happens if we change the scope of the English greeting service to prototype. How does Spring handle the @PostConstruct and @PreDestroy annotations in that scenario? Let's change English greeting service scope to prototype. Start the application. As we can observe from the logs, the English greeting service class is initialized and subsequently, the @PostConstruct method is called. This observation is crucial as it confirms that regardless of whether the bean is scoped as singleton or prototype, Spring ensures that the @PostConstruct method is invoked after the bean's instantiation and dependency injection are complete. Spring's handling of the @PostConstruct annotation remains consistent across different bean scopes. This means that every time a bean is created, whether it's a singleton bean created once per application context or a prototype bean created anew with each request, the @PostConstruct method is reliably called. This guarantees that the bean is properly initialized before it's used. For prototype beans, each new instance will trigger the @PostConstruct method, ensuring that each instance is fully initialized. This is particularly important for prototype beans since they are not managed beyond their initial configuration and instantiation. In the case of singleton beans, the @PostConstruct method is called once when the bean is first created. This setup is typically used to perform any initialization that requires all dependencies to be fully set. Stop the application. As noted, after stopping the application, we observe that the @PreDestroy method is not called for our prototype scoped English greeting service. This behavior is a key aspect of how Spring manages prototype beans and underscores a significant difference from singleton bean. In Spring, when a bean is defined with a prototype scope, the container creates a new instance each time one is requested but does not manage the complete lifecycle of the bean. This means that the destruction phase, including the invocation of any @PreDestroy cleanup methods, is not managed by Spring. Since Spring does not manage the full lifecycle of prototype beans, it does not call the @predestroy method when the application context is shut down. For prototype beans, any cleanup required must be handled explicitly by the developer. If your prototype beans hold resources that need to be released, such as file handles, network connections, or large in-memory data structures, you must manually ensure that these resources are cleaned up. This might involve keeping track of bean instances and explicitly calling cleanup methods when they are no longer needed. A question arises when dealing with prototype beans in Spring. The container doesn't automatically call the @predestroy method upon application shutdown. You might wonder how to properly manage and clean up resources when the beans use ends. Fortunately, there are practical solutions to ensure that resources are handled properly. One straightforward method is to manually call a cleanup method in your application code. This approach gives you control over exactly when and how resources are released, which is particularly useful in more complex scenarios where resources need to be managed carefully. Alternatively, you can instruct Spring to destroy this bean. To adapt our greeting controller for handling the English greeting service with a prototype scope, we can change the way the service is accessed. Instead of directly injecting greeting service, we'll inject the application context itself. This allows us to retrieve a new instance of English greeting service whenever needed, leveraging its prototype scope effectively. Remove greeting service variable. We've removed the direct dependency on greeting service. Inject the application context, which allows us to request beans dynamically. In the getGreeting method, we retrieve a new instance of English greeting service each time it's called. This ensures that each interaction with GreetingController uses a fresh instance of the service, respecting its prototype scope. Oops, we are not able to retrieve the getBean method. Actually, we imported the wrong application context. We require the Spring Boot application class. Use org.springframework.context.applicationContext. Get English greeting service bean from application context. When we exit from getGreeting method, the greeting service object is no longer required, so we need to do the cleanup for greeting service in the finally block. First, you need to get the AutoWire-capable Bean factory from the application context. This factory is capable of managing Bean lifecycle events including custom destroy methods. Once you have the factory, you can use it to destroy the prototype bean, ensuring that any @predestroy annotations within that bean are respected and called. Start the application. Open a web browser. Type localhost 8080/greeting in the address bar and press enter. Now that we've received the expected response, let's switch back to IntelliJ. As we observe in the logs, Spring first creates an instance of English greeting service. After the bean is instantiated and its dependencies are injected, Spring calls the @PostConstruct annotated method. Later, when we instruct Spring to destroy the bean, Spring processes cleanup tasks. Before actually destroying the bean, Spring calls the @predestroy annotated method. Today we explored how Spring manages the lifecycle of beans, focusing on the important roles played by the @PostConstruct and @predestroy annotations in both singleton and prototype scoped beans. We've seen how these methods ensure proper initialization and cleanup, contributing to robust and efficient application behavior. Thank you all for tuning into this detailed walkthrough. If you found this tutorial helpful, please don't forget to like, subscribe, and click the notification bell to stay updated with our latest content. Your support helps us bring more tutorials like this. Until next time, happy coding!